We've scoured the earth to find the world's toughest tools, from the dynamic compactor pounding the earth to the concrete pulverizer. This elite group of tools operates with a single purpose: destroy anything that gets in the way without mercy. They are the slashers and crushers. The pulverizer uses its jaws to strike specific targets, which is why it will be deployed on its next mission in a small town in southern Massachusetts. The job: demolish an abandoned mill. But unlike today's easily bulldozed prefab factories, this fortress is constructed from granite buttresses, reinforced concrete, steel and iron.
That's our goal right now, is to get that 3-story down as soon as possible.
It's a very large job with some massive structures on it. It's not every job that we get to utilize a pulverizer this big. It's an ideal tool for the tasks that we have ahead of us. We have neighbors to contend with, so we have to do this work as surgically as possible with as little interference to the surrounding community.
So, demolishing the derelict mill will be tough, but the crew has one of the world's toughest tools at hand. And operating the pulverizer will be Eddie Olette.
That particular machine, oh, it's incredible. You can pretty much crush anything. It's fun to know that you're disintegrating something.
What makes the concrete pulverizer ideal for this job? Its speed, its strength, but most of all, its jaws. The jaws have the power to lift a 4.5-ton block of concrete. And the precision to drop it wherever it wants.
This pulverizer is designed for heavy demolition jobs where you have very thick sections of concrete that need to be pulverized on a large carrier.
These teeth pack a punch of 8,500 kilograms per square centimetre. That's over double the jaw power of a Tyrannosaurus Rex. The jaws have vertical rows of teeth, 4 serrated rows on top, 5 on the bottom. This huge amount of surface area allows it to crush any building material up to 1.5 meters thick. And the jaws are replaceable, so they always stay razor sharp. This versatile tool can even be used as a battering ram with a hammering force of more than 8,000 Newton meters, enough to flatten a 1.5 meter filing cabinet to 12 centimeters. But to get the pulverizer going, it needs power. And that might behind the bite is a 6-cylinder turbocharged diesel engine of 697 horsepower. That's more than a Lamborghini Murcielago SV. But the machine doesn't come without danger, and being run over is the #1 cause of death.
With the machine as large as this is, the visibility is limited. You just have to be very careful what you do and where you move to. Somebody get behind you. You have to watch out for yourself as well as the people around you, because anything could happen.
Today's first job is to crush debris from around the corner of the old mill. In the past, this debris would have been loaded into trucks and taken off to a landfill site. And this is not the cheap option, as the demolition companies have to pay dumping fees.
We can't afford to bring stuff to landfills. It's a fortune now to get rid of it. Landfills don't want the stuff.
But the concrete pulverizer can turn this debris into cash. This is because its jaws can sort and load the materials, which can then be sold. And one person's trash is another person's treasure. The granite blocks are crushed and sold as hardcore. The wood, bricks and iron are sold as salvage.
Our goal on a job is to come out at the end with 90% recycled.
The concrete pulverizer quickly demolished the mill's wood framing and concrete foundation. Now it's up against a much tougher opponent, granite. Granite is primarily quartz and feldspar, two of the hardest minerals on Earth. To demonstrate just how formidable granite is, we're subjecting it to a hailstorm of 5mm bullets, which travel at 850 metres per second. Even under these extreme conditions, granite refuses to break, while the breeze blocks below it are completely destroyed. After 8 direct hits, the granite is barely scratched. When the granite is subjected to a crushing force of 250,000 kilograms, the boulder doesn't stand a chance. The pulverizer can withstand that kind of force and not break itself because it's built with 7 types of heat-treated steel.
The steel in this pulverizer is actually thicker and stronger than the upper hull structure in an M1 Abrams main battle tank.
The concrete pulverizer goes head-to-head against a motley crew of cast-iron columns, wooden beams and reinforced concrete. It has munched through granite and sorted through iron, but now it's about to hit a wall.
We're going to take the front face of this building down. It's a concrete wall approximately 3 foot thick, so it's very strong.
The concrete pulverizer has bitten off more than it can chew. Its jaws are too narrow to swallow the wall whole.
The tool is powerful enough, but it's not big enough, or shall we say wide enough. Probably only take down a small section, like say 1 column or 2, it just won't work.
The situation could be fatal. The more pieces created during a demolition, the greater chance of a collapse, crushing Eddie in the cabin.
He starts putting little pushes on it. I'm afraid of another piece coming in at the machine and the operator and him getting injured because he's right under it on the inside of the footprint.
The men's solution is simple but effective. Widen the jaw's surface area by clamping onto a steel beam. It will turn the jaws into a 4.5 metre wide battering ram. Now to demolish the wall. As the dust clears, we can see how successful the job is.
With the I-beam inside of the pulverizer, it went absolutely perfect, and that wall really didn't stand a chance.
The concrete pulverizer. It rips into any building material, then turns the wreckage into gold. As the concrete pulverizer cleans up, just down the coast in Pennsylvania, a huge paperweight is beating the earth to a pulp. Weighing thousands of tons, buildings must be constructed on solid ground. If not, they can simply collapse. So, engineers have designed a specific tool to compact the soil to make it more stable. Meet the pounder. The process, deep dynamic compaction. The weapon, an 18-ton steel weight. The concept is simple. Lift the weight 6 stories high and drop it. The result is crucial as the pounder increases the density and strength of the soil, thus creating the foundation to support the weight of the building. At over 16,000 kilograms, the pounder outweighs 6 US military Humvees. But without a machine to drive it, it's just an oversized paperweight. Its power, a 150-ton crawler crane. The job in store for today, to compact 7,000 square metres of soil until the ground can support a massive warehouse.
Today we're improving an old municipal solid waste landfill because they want to put a large 500,000 square foot produce warehouse on it. And we're using dynamic compaction to improve bad ground.
The job requires 2 cranes, and they're rolled out to begin the job. It looks easy just releasing the pounder from 18 metres, but requires expert timing.
It's very stressful what they do. They have to let that weight free fall. As soon as that weight touches the ground, they have to catch that chain. If they don't hit the brakes as soon as that weight hits the ground, it could be very costly. Cable breakage, major crane breakage, you cannot make a mistake. There's no room for error.
The stakes are high for this high-impact tool. To demonstrate the pounder's precision and power, we've given it a couple of unusual targets. First, a 22-inch television that's about to experience the force of gravity. With the weight 15 metres in the air, the operator takes aim. As the 16-ton pounder makes contact, the TV's plastic is sheared off and the glass screen is smashed. As the power cord and other debris become airborne, the pounder settles into the ground. When it's removed, all that's left is a flat-screen TV. 100% accuracy from 18 metres is impressive, but this is a tool that's all about power. To demonstrate, let's introduce Target 2, a 2,000 kilogram, fairly well-used family car. Newton meters demolishes the roof and completely destroys the structural steel framework. But the pounder's real impact takes place deep below the ground.
We're trying to treat anywhere from 10 to 25 feet in depth from the ground surface.
If the shock waves of the pounders don't reach deep enough underground, the land will be unsafe to build upon. To guarantee proper penetration, the crew must be accurate with every drop. They've done their homework. A computer-designed graph tells them exactly where to drop the pounders. If each grid mark is accurate, the shock waves at each impact point will spread and actually multiply the overall force. This makes the result of each impact stronger, wider, and deeper.
The flags mark the crane operators where we drop the weights.
The impact force from the deep dynamic compaction is so powerful that nearby structures can register the vibrations. Seismic waves travel across surfaces. Slow down the impact and we can actually see the shock wave. They know where the smashing begins, but where does it end? Throughout the day, the crew uses a seismograph to measure vibrations generated by each drop.
The seismograph is going to allow us to document whatever vibrations that we're producing, and so we know exactly what vibrations are leaving our site. We've got to be very careful that we don't produce any vibrations that might harm any critical structures around.
The readings show that the buildings nearby will remain unaffected. They also confirmed that the impact force unleashed by the pounders has transformed a shaky landfill into solid ground. They've actually made the Earth stronger. After a full day of relentless ground pounding, the job is complete. And the dynamic compaction pounders have proved their toughness and paved the way for a new food warehouse. Fighter jets also take a pounding, as they have to withstand the demanding conditions of supersonic flight. They have to be exceptionally strong and lightweight. That's where military-grade aluminium comes in. And one tool trusted to forge this crucial material is at the Alcoa plant in Cleveland, Ohio, the 31,000-ton hydraulic forge press. Forging material is the process of smashing a block of solid aluminium into a desired shape. And to achieve military standards, Alcoa's press is built to do serious damage. This tool stands taller than a 10-story building.
It's a heck of a press. Gets the job done.
It's built using over 6,000 tons of steel, with a crushing force of 63 million tons of pressure.
There's only 4 of these in our whole country, and we house 2 of the largest right here in Cleveland.
Today, the forge press's job is to build components for the US Air Force.
We're working on some large bulkheads. They're going to go in the JSF Joint Strike Fighter.
A bulkhead is the primary structural support for the wing and engine compartment for the F-35, one of the fastest jet fighters in the world. One bulkhead can weigh over 2,000 kilograms and span 7 meters in length.
The parts we forge physically hold the aircrafts together.
First of all, the crew must prepare the die by lubricating it with oil and water. Otherwise, the aluminium workpiece will melt into the die. When the lubricant hits the aluminium that's been roasted to 370 degrees, the intense heat causes it to combust. In slow-mo, it becomes obvious why operating the forge press is such a dangerous job, but one worth doing because forged aluminium is 300% stronger.
There's no margin for error. These F-35s will be someday maybe asked to be in deadly dogfights. They must be able to withstand that type of pressure.
Once the fire and brimstone subsides, the crew brings in the aluminium alloy block.
After the lubrication process is complete, it goes into forging mode.
The block's been heated to 370 degrees and is transported by a specialised arm that places the softened aluminium into the forging dies. The workpiece is in place. A flick of a switch by the operator breathes life into the massive tool. And this forge press can produce a huge force of over 3 million kilograms of pressure. It's all needed because it's up against one of the toughest alloys. To demonstrate how tough this military aluminium is, we've struck an ingot of it with a solid steel pickaxe. Because the aluminium is supercharged with copper, magnesium and zinc to boost its strength, 225 kilograms of force barely makes a dent.
Different alloys of aluminum that we've developed are super strong and super lightweight. You wouldn't want to make a plane out of steel. It'd take too much power to get off the ground.
As the die is lowered towards the aluminium block, the stamping imprints are clearly seen. These are the negatives that will create the complicated contours of the bulkhead itself. When the die presses down, this unique pattern is imprinted directly onto the aluminium alloy. That's when the 32 tons of muscle kicks in. And it's all created with the world's most basic substance, water. 2 water tanks containing 190,000 litres serve as a hydraulic reservoir.
But if you drain those tanks, it'd be like dumping 2 backyard pools, built-in pools.
The pressure from the water gives the forge press its strength. The pumps generate a pressure of 310 bar, and move the water at 600 litres per minute. This creates a hydraulic advantage, so in this instance 310 bar is increased to 4.5 million. An advantage that was not realised in American forge presses until a little military espionage was committed. During World War II, Americans discovered high-strength aluminium in the German planes that had been shot down. This meant Germany had the largest forge presses in the world. When the war ended, both American and Soviet agents raced to recover the technology. The full pressure is charged into the system and the operator can press some metal.
It's really super critical when we set up an operation on the press that we match everything to the process notes. We have to watch dwell time, tonnage, and forging speed.
Any deviation from these strict specifications could cause the failure of a supersonic flight, a deadly consequence.
If that particular part fails, the plane's going to come down.
The controller constantly regulates the speed of the die's descent. After 30 seconds of forging, he chooses to slow down the speed. And this adjustment means the pressure is mounting up. The 30-centimetre thick aluminium plate is crushed by 40%, as 15,000 kilograms of pressure clamps down on the aluminium. As the pressure extends deep into the metal, its structure begins to change. The aluminium atoms begin to roll over each other into new, stronger positions. The metal is permanently changed, and in this instance, a 2,250 kilogram bulkhead is formed in a short 1 minute and 13 seconds.
The precision and strength of the material that we forge through this is one of the key characteristics in building an aircraft or a military vehicle.
Finally, the manipulators move in to retrieve the forged aluminium. Air forces will always demand strong, lightweight aluminium.
I've been here for a long time, and the one thing I have to say is this very large press is one ticking machine.
The hydraulic forge press is one of the world's toughest tools. As another plane begins to take shape, in New Jersey, 140 cubic meters of rock is getting crushed by a 35-ton rock saw. To build roads across the United States, crushed rock is needed. Lots of it. Where can it be found? New Jersey. What's needed to extract it? A machine that's tougher than earth. Meet the Tesmec 1100 rock saw. 10 meters long, 4 meters tall, and 2.5 meters wide, this rock saw weighs 34,000 kilos. The 3.5-ton steel cutting wheel, measuring almost 4 meters across, is the only saw built able to tackle the hardest rock in North America, trap rock. For Vinny Torrido, it's his biggest enemy.
Today we're going to head out to the quarry and cut some trap rock. It's pretty tough stuff.
Today's quota, cut up 1,500 meters of this incredibly hard, once molten rock. That's an intimidating 340 tons. But simply cutting the trap rock will not be good enough. To be used for road construction, the trap rock must be crushed into precise bits. The resulting rock fragments are mixed with cement and asphalt to make the most durable of all road surfaces.
Without it, we can't have roadways, but we need that for our infrastructure. And the rock saw is very important to get it.
As necessary as trap rock is, mining it with conventional tools is futile. Until recently, road builders depended on pneumatic hammers. These tools drive a chisel into weak and ordinary rocks 1,500 times a minute with a force of more than 40 Newton meters per stroke. Excellent against concrete, but for rocks that originated as molten lava, like trap rock, it is pointless. The rock saw takes a radically different attack, the same method as the common circular saw. The circular saw has a 25cm tempered steel blade that spins at 20 Hz. When slowed down, it can be seen that the teeth do not grind away at the wood, but tear at it, one tooth at a time. The rock saw does the same to the trap rock, but at a much higher rate. Its wheel has 100 teeth biting into the quarry floor 2,100 times per minute. That's 35 times every second, nearly twice as fast as the circular saw. That muscle is all due to the rock saw's 6-cylinder, 370 horsepower turbocharged diesel engine. To get a sense of this massive machine's power, the rock saw tackles a solid oak-framed sofa. It devours the couch in 4 seconds. When the video is slowed down, the blade's 17,600 Newton meters of downforce just eat the sofa for lunch. Halfway through the task, the rock saw is tearing up the earth. Vinny keeps the tool at full throttle to continue the battle. When a common saw tries to cut through trap rock, it doesn't make a scratch. But hardness isn't its only attribute. The rock has a unique structure that makes it even tougher to cut. Small holes deep inside the trap rock actually act as shock absorbers against the force of the saw. This makes fracturing the rock incredibly difficult, but the rock saw is much more than just brawn. It combines precision with its power. Precision in the form of high-tech teeth. Each of the Tesmec rock saw's cutting teeth is like a 5cm chisel, and the saw's wheel has over 100 of them. The tooth shank is hardened steel, but it's the point that causes the real damage. Each tooth is tipped with tungsten carbide, a nearly invincible alloy. Tungsten carbide is one of the hardest man-made materials in the world.
The rock saw can cut through unbelievable surfaces that you would never expect.
To demonstrate the rock saw's precision, it is tested against a wall to see if it can maintain a straight cut. When the video is slowed down, we can see concrete being discarded with every strike of the teeth. But the result is conclusive. The brutal tool creates a surgically precise gash in the 1 meter thick wall. In the quarry, the day's about done, and the rock saw's crew is digging up the last few meters of trap rock. Their quota accomplished. As long as America needs roads and roads need trap rock, the rock saw will be digging away, showing why it's one of the world's toughest tools. In the US, to keep up with energy demands, worthless railway sleepers and telegraph poles are burned to produce electricity. And a timber mill in Fleetwood, Pennsylvania has piles of untapped energy. As well as 2 giant wood-eating machines that can grind them up. The wood hog and the tub grinder. Weighing in at 45,000 kilos, the wood hog is a heavyweight that reduces massive telegraph poles and railway sleepers into small chunks of wood. While its partner, the tub grinder, beats what's left into a pulp. The 45-ton tub grinder can hold over 14 cubic metres of wood in its massive 4.5-metre belly.
Well, I'll tell you what, they're about two of the baddest pieces of equipment on the market.
The two work together, shredding the wood they're fed. And today's job for the wood hog and tub grinder? Reduce 13 tons of telegraph poles and railway sleepers to dust. That's almost 14,000 kilos of pulp in one day. Before these huge machines arrived on site, this just wasn't possible. Crews relied on the same small wood shredders you use in the back garden. They're not bad for chopping branches, but railway sleepers are 10 times the size and just can't be shred by the chipper. Men that run the wood hog have good reason to scoff at the roadside chippers.
That 6600 is so badass I could run that little chipper right through that.
The men start the process by feeding the first batch of sleepers and poles into the wood hog. Fed into the machine by a hydraulically powered bed chain, the wood is then grabbed by the spiked feed drum.
The telephone pole is about 800 pounds apiece. It'll take 4 to 5 at a time and shred it. Bam!
A high-speed camera shows the brute force of the wood hog. It happily munches the massive wooden poles, reducing them to smaller chunks. Hidden inside this toughest tool is the key to its destructiveness, the hammer mill. At the heart of the wood hog live 30 tungsten carbide and steel hammers. 16 times harder than wood, the hammers don't waste time slicing it, they just smash it. The hammers need to be tough, as the telegraph poles are littered with steel spikes and plates, objects that would destroy the blades of normal cutting tools. The power required to smash a 16-metre tall telegraph pole into 12-centimetre chunks is massive. And the wood hog uses a 30-litre, 1,100 horsepower engine to drive the relentless hammer mill. In no time, the wood hog has reduced the first batch of today's telegraph poles to firewood. The next stage, transfer the chunks of wood to its partner in crime, the tub grinder. But before the tub grinder can get to work, the steel and spikes left by the wood hog have to be removed, or they could destroy the tub grinder.
You could lose a tip, bust a holder up.
The solution? A big magnet. As the smaller chunks make their way out of the wood hog, the tub grinder scans the conveyor with an electromagnet. Any chunks of wood that contain embedded steel are snatched away.
The more metal you run through it, the more breakdowns you're going to have.
Once the wood is sorted, the 45,000 kilo tub grinder gets to do its job: pulverise.
It is the biggest and baddest thing I've ever seen, and it can remove a lot of material very fast.
So fast that every hour the tub grinder churns out enough wood pulp to power 30 homes for a day.
A finished product going outside of the machine will fill about a 48-foot tractor trailer every 11 minutes.
And much like the wood hog, the speed is due to a hammer mill of its own. As the 4.5-metre tub rotates, wood is forced against the tungsten carbide jaws of the hammer mill, which claws and shreds it. 4.5 tons of force which smashes the wood into bite-sized pieces.
As the material's being fed into the hammer mill, it is just eaten alive.
The only time it gets a break is when it goes into reverse to clear its throat. This eliminates the dangerous procedure of sending workers into the machine to clean it by hand. The wood hog and the tub grinder have exceeded the day's target. Over 14 tons of telegraph poles and railway sleepers have been smashed to a pulp. Enough fuel to power a small city.
Pound for pound, these machines are worth their weight in gold.
And with billions of kilograms of wood waiting to be turned into much-needed energy, the wood hog and tub grinder are on hand, proving that they are two of the world's toughest tools. As tons of railway sleepers await destruction, in the US state of Vermont, the largest quarry chainsaw in North America is cutting into the earth. Deep underground in a Vermont quarry, USA, is a prized building material, marble.
This is the largest underground marble quarry in the world. Okay, it's 40 acres.
For over 100 years, the Danby Quarry has been providing marble for high-quality building constructions around the world.
How proud are you when you see the U.S. Supreme Court building or the Jefferson Memorial? This stuff comes from here.
But over the last 10 years, China has entered the market. So, to ensure Vermont marble stays economically viable against the stiff competition, a new tool has entered the quarry. Meet the quarry chainsaw. The quarry chainsaw, also known as the gallery saw, was built to carve multi-ton blocks of marble out of the earth. Its cutting arm can rotate 360 degrees from vertical to horizontal and back again. The result? Perfectly measured cubes of pure marble. It weighs in at 25,000 kilos and is the largest marble chainsaw in North America. It's a small 3 meters at rest. But when called into action, the cutting arm can raise to over 6 meters. Hard to reach corners are not a problem. To compete against the competition, every day the men that operate this machine are given a target. This afternoon's job? Make a series of horizontal and vertical slices into the quarry wall and extract one 22,000 kilo cube of marble.
The gallery saw cuts blocks that are approximately 9 foot by 6 foot by 5 foot.
This block is chosen using an elaborate quarry extraction scheme. This linear grid essentially turns the quarry into a huge superstore of marble stock. As the powerful machine approaches the wall, it is evident that the designers enlarged a tried and tested tool. The chainsaw uses a 35cm cutting chain that rides on gear-like teeth. This constant rotation of the cutting blades make it seem like it's slicing through the wood. But when the video is slowed down, we see the chain actually digs its way into the wood. While the blades cut the wood, they also excavate the dust and debris, clearing a path to keep digging further. The quarry chainsaw uses the same principles. It just requires a lot more muscle to cut through a material as tough as marble. Marble is a dense material and is also very dangerous to mine. A 36-kilo chunk of marble falling from a height of almost 2 meters creates more than enough force to crush a human skull. Slowing down the footage, it becomes clear that the marble would instantly kill the worker. To further illustrate the power of marble, we've placed a camera 90 meters from one of the many blocks in the mine. Compare the size of the marble block to the crewmen in the upper right-hand corner of the frame. When the block is knocked over, the result is explosive. Slowing the video down, we can see the impact launches fist-sized rocks towards the camera positioned 90 meters away. These dangerous projectiles are common in the marble quarry. Because marble is a dangerous material to quarry, the operator uses a remote control system so as to stay out of harm's way.
The gallery saw is moved with just a simple remote control box. It's like playing Nintendo. You're talking about a 25-ton machine here that you can move with your pinky.
The chainsaw slices into the wall. The operator guides the cutter horizontally, then prepares to change direction. The power of the chainsaw easily cuts through the marble. But in this region of the quarry, the chainsaw has more than marble to contend with. As they continue cutting, they confront a tougher enemy, quartz. Quartz hides throughout the marble in tight crystalline veins. If the saw blade hits these quartz veins, it could destroy the very expensive blade system.
When you get into a harder material, you don't want the chain of the sawhead blade to start chattering.
To prevent the problem, the machine designers took this into account when developing the saw's cutting blades. The saw runs at just 52 revolutions per minute, but its cutting blades are positioned at different angles. This angle is referred to as the kerf. The greater the angle, the greater the kerf. This angular structure allows the incision to be larger than the saw blade itself, which prevents binding when it hits the harder materials. The chain on the cutter also beats quartz when it comes to hardness. It's made of the hardest substance on Earth.
We use the polycrystalline diamond. It's just a synthetic diamond, not the woman's best friend and all that kind of stuff.
This diamond compound has been applied to the cutting tooth in layers, so as the outer layer of diamond crystals wear away, a new layer of sharp crystals are revealed. This two-pronged attack keeps the quarry chainsaw working even when faced with unpredictable materials found in the quarry wall. The cut is complete. A forklift starts the removal process. This top-quality marble will be milled and then shipped around the world.
The gallery saw is a real badass new tool.
To keep up with global competitors in the construction industry, these US quarrymen depend on the power and agility of the quarry chainsaw. One of the world's toughest tools.